Hi, guys. Happy Thursday. Today, let me share the agenda with you really quickly. Here's what our goal is for today. So, today, we're going to try to talk more about what atoms are. So, our goal is to define the word atom. And by the end of class, can we draw a correct representation of an atom and what's inside of it? So, it's basic parts, okay? And then there's no homework. Woohoo! All right, so let's get started. So, the very first thing I want you to do, and there's two options, is you can either go into Google Classroom, and if you notice today, you've got Adam's intro notes, and there's that Adams packet that we've talked about that you could have printed. If you did print off the Adams packet, I want you to go into it and get it right now. And we're basically going to go past this triangle, this pyramid, and we're going to go to the sheet that says atoms. Okay, so if you've got a paper copy at home, I want you to get out the sheet that says atoms. And I also want you to find three colors. So they could be three highlighters, three markers, three colored pencils, but three different colors. So do that right now. If you've got the atoms paper, get that out and get three colors. And you can pause the video if you need to. Okay. If you don't have that, then you're just going to follow along with me in the Adams intro notes. And I actually want you to actually open yours up. So go ahead and click on it and open it up. Okay. So either way, today what we're going to be talking about is continuing to talk about matter. And yesterday you should have watched the Bill Nye video, as well as we've been talking about what matter is all week, right? And we should know that matter basically has two things that we need to know. Matter takes up space. Okay, so and whether it's a small amount of space or a large amount of space is really kind of very different, right? It can be a very, very small little thing like atoms that we can't even see, or it can even take up space like air. We don't really see the space that air takes up, but it's there, right? Or it can be something that takes up a massive amount of space like a plane, right? And also, matter is anything that has mass, so anything that has some kind of weight to it. All right. So even if we think of air, air takes up space and it does have some mass. It does have some weight. We don't really feel a lot of it when we breathe or when we walk around. But if you were to go to the top of a mountain and go hiking or go to some place that had a lot of mountains or high elevation, you would really feel it as you were breathing or you're trying to work, or if you went for a run or something like that, you would feel more of the air pressure, the air, the mass that it holds. Okay, so anything that's matter, and pretty much everything is matter, right? Everything has mass pretty much and takes up space. So your computer, me, my glasses, my piece of paper, my pen, my coffee cup, my phone, my cat that's sitting across from me looking at me strangely, the sun I can see out the window, the grass, the tree, all of that stuff is matter. Okay, if you remember, the only thing that's not matter is stuff that's like energy. So sound waves, energy, heat, light, those kinds of things are what we call energy instead of matter. But pretty much everything is made of matter. Okay. And comparing to our last unit, we kind of just ended a unit that has a similar background in terms of when we talk about really small things. So we just finished a unit where they were talking about organisms or living things, right? And we said the very smallest parts of living things are called cells, right? The cells come together to make us and other living things, right? Well, when we talk about matter, the smallest parts of matter that come together are called atoms, okay? And atoms come together and build to make different stuff. So I'm made of atoms, you're made of atoms, this phone is made of atoms. Those are the smaller things, kind of like cells that make up matter, okay? Even our bodies are made up of millions and bazillions of atoms, okay? And atoms are kind of like the building blocks of matter. I think of atoms, the easiest analogy I think of is Legos. So I think about Legos and I think that, okay, some Legos have like that one dot on them, right? Some have two, some have four, some have eight. Some of them are really thick, some of them are thin, some of them are green or yellow or red or orange. Actually, I don't know if they have any orange Legos. I'm sure they do. But there's different kinds, right? And there's different sizes. And I could have millions of different kinds of Legos in my room, but depending on what I use, I can make different stuff, right? So that's why a piece of pizza and myself are both made of atoms. We don't look the same, but basically all that happened is we're different atoms were put together to make us. So I have some of the same atoms that pizza does. Okay, it's just pizza's atoms were put together kind of and combined in different ways than I do. Okay, so atoms are a lot like Legos. If I had a giant pile of Legos in front of me, maybe I'd make a castle. Maybe you would make a giant city or an animal or something like that, right? And so atoms are the smallest parts, the building blocks of matter. All right. And we can kind of see that in the next slide, right? When we did our pyramid earlier this week, atoms are the tiniest parts, right? And you keep putting them all together and larger and larger and larger, and we get to the whole entire world. So everything is made of atoms. Everything is possible because of atoms. So atoms are the tiniest thing that we're going to study all year long. Okay. When we think about and talk about atoms, this is usually what scientists show them out to be as, because unfortunately, we can't use a microscope to see atoms. Okay. There are only like a handful, I think, machines around the country that can actually look at and analyze atoms. And they're not microscopes. They have to be more powerful than that. Fermilab, which is not too far away, has the ability to look at and kind of see what an atom looks like. But based on what they have shown us and talked about, this is what atoms look like. We think that they're kind of in this shape where there's what's called a nucleus in the center. So all these pictures have a nucleus. And then there's these electrons kind of floating around. And sometimes they draw them in circles or sometimes they have them in rings. Okay? But what we're going to do today is go over the different parts of the nucleus. Okay? So let's start with this. If you have the paper copy, you're going to get one color out right now. And what I would like you to do is color in this negative part here. Okay? So let's say you chose red. You're going to color this in. That's an electron. So now you're going to color the electron into the key. And then when you go down here, you're going to color in all the negative electrons here. Okay? So that's what you're going to do if you have the paper. If you don't, you're going to follow along with me. So electrons have a charge. So there's some kind of electrical charge to them, and they're going to have a negative charge, negative. So you want to write that in onto your sheet also. Electrons have a charge of negative, okay? And the way that the way that I remember that is that I think of electrons sounds like the word electricity. And if you think about what people say about electricity, they're always like, oh, stay away from electricity. Or think about if you got shocked by like an electrical shock, right? Or electricity, it would be a negative experience. So electrons have a negative charge. So a lot of times when we draw them, we put this negative, like minus sign inside of them. So again, if you are on paper, you're going to color in these negative electrons, okay, on the outside. If you're with me, you're going to color these by just moving them to where they go in the circle. Okay, so electrons are negative and they are on the outside of the atom. So go ahead and do that with me. And if you need to, you can pause the video. Okay, the next part that we're going to talk about is called, whoops, I didn't go to the right spot, protons, okay? So now I want you to pick a different color if you're doing the worksheet. If you're not, you're just going to go along with me on the slides here. Okay, but protons, when I think of the word protons, I notice there's a P. So P, it starts with a P. Also, it starts with the letters P-R-O, which mean pro. And a lot of times when I talk about the pros and cons of something, I'm talking about the good or the positive and the negative, right? So if I say, what are the pros and cons of having fourth period lunch? You might say, okay, the pros are, and you'd be talking about the positive things. So protons have a charge that is positive. So please type or write that into your notes right now. Okay? And protons, the positive, are always in the center of the atom. So I'm either going to color them in on my sheet, a different color, and color in the positive circles, or I'm going to color them in on my sheet by dragging them in and kind of making them look like a bunch of grapes. I know it doesn't look perfect, but there we go. Okay, take a minute to do that if you need to. Okay, and then the last part of an atom is called a neutron, which makes me kind of think of like Jimmy Neutron, but I also think of the word neutral. And if you're familiar with the word neutral, neutral is kind of like when you don't join a side, right? So if there's a war and my country remains neutral, I'm not on either side. Or let's say my two friends want to go to different places to eat, and I say, oh, I don't want to start a fight, so I'm going to remain neutral. That means I'm not going to say one or the other. So that's kind of what a neutron is. A neutron has a charge that is neutral or basically nothing. Okay? So when we draw neutrons, they don't have a positive or a negative inside of them, and they go in the center with the protons. So I'm going to drag them into the center. So again, if you have the paper version, pick a new color for the neutrons. They have a charge of neutral or nothing, and you're going to color in the ones without positive or negative. Okay, those are neutrons. All right. So when you think about an atom altogether, you've got this positive center and this negative outside. Okay. So when we talk about the whole thing, it says the nucleus is made up of blank and blank. Well, we've got blank and, neutrons. So the nucleus is made of protons and neutrons. So if you go to your sheet here, you'll notice that it says the nucleus is made up of, you're going to write protons right here. Okay, protons. Okay, and this doesn't have it on the sheet, but one thing I wanted you to know is that where do electrons go? They float around the outside of the nucleus. Okay, so protons and neutrons in the middle, electrons on the outside. Okay, so if you look at your final part of your paper right here where it says lithium atom, I'm going to show that on my screen also. And if you look at this, here's a picture of a lithium atom. Lithium is commonly used in batteries, but here's what a picture of a lithium atom looks like. And if you look at it, we can now count up the parts, right? How many electrons does this lithium have? Well, if you look at it, electrons are negative, right? Electricity negative. So 1, 2, 3. So I'm going to type in 3. If you're doing that on the paper, you can write it in right here, 3. Okay? Then how many protons does it have? Protons, pros, positive. So 1, 2, 3. 3 protons. That's interesting. Protons and electrons are the same number. Let's look at neutrons. Neutrons, if you remember, are neutral or have no charge. So I'm going to count the ones that don't have anything in them. 1, 2, 3, 4. There we go. Neutron. Whoops. Neutrons, okay? So if you notice, when I have an atom, they have the same number of negatives as they do positives. They balance out. So there's 3 positives in the center, 3 in the negative, or 3 negatives around. So it's almost kind of like a math problem. If you had positive 3 plus negative 3, you'd end up with 0, right? So it kind of neutralizes or ends up being nothing, okay? And if you notice that on your sheet, it says atoms have the same number of protons and electrons. Okay, so that's important to note. All right, we're going to do 2 other things today. What I did is I showed this YouTube video. It's just kind of massively cheesy, but a family is singing about atoms, like the Addams Family. And then if you go all the way down to 1, 2, 3 more slides. So we're on looks like slide 13. You're then going to watch this TED Ed video about just how small is an atom. Okay, so that's all we did in class. Please skip these slides. Skip 11, 12, 14, and 15. We're going to get to those tomorrow, okay? But for right now, when you're done, watch this goofy little atoms video and watch the one that's a TED Ed video. And then you're done, okay? Have a great day. There is no homework. Bye-bye.